This video is over lesson 98, solving quadratic equations by factoring. So ladies and gentlemen, you can see that I've already got a lot laid out here. We're going to talk it through. If you want to pause the video and get it copied, you can do that, or you can copy as we talk. So I'm going to slide this up just a little bit so that way you have everything there on your screen. And now we're going to talk. So we got a little bit of vocab we got to deal with here at the beginning of the lesson. So this lesson introduces a new vocab term, the term root of an equation. It's very simple, as you can see. It's really just saying the solution of an equation. I got a little bit of a eraser. There we go. The solution of an equation. Remember, a solution is just any value of your variable that makes the equation true. So root here is just another way of saying solution. Now when we talk about a quadratic equation, we need to understand that we're talking about an equation that's made up of polynomials where the highest degree is 2. So that means somewhere in there you've got an x squared. Now you could also have x terms, you could have constants, but you have to have an x squared. More than that, and I didn't put this in my definition, but when you start to simplify and solve for things, if you have an x squared somewhere and you have another x squared somewhere else, those two x squareds can't cancel each other out. So when you're all done simplifying things, you still need to have an x squared. And so we can see that particularly when we look at the standard form of a quadratic equation. So the standard form is ax squared plus bx plus c equals 0. And so a cannot be 0. A cannot be equal to 0. Because we need that x squared term in order to make this quadratic. B could be 0, C could be 0, but not A. Speaking of 0, the standard form, we say the equation is set equal to 0. So we've got everything else over here, and then on the other side we just have 0. So this is standard form. The equation is set equal to 0. So anywhere you see equation is set equal to 0, and you got an x squared, you know that's the standard form of a quadratic equation. Now, to connect this to things that we've talked about recently, if we were to take the roots of a quadratic equation, if we were to take a set of all of the roots of a quadratic equation, so all the solutions of a quadratic equation, so the roots would be everything here that makes this true. This is going to be the same set as the zeros of the related quadratic function. So instead of 0, if we have f of x, well, there's my quadratic function. So the zeros, remember, is just wherever we make f of x 0. So hopefully you can see the connection here that when we talk about the roots of a quadratic equation, or if we talk about the zeros of a quadratic function, we're really talking about the same things. So that's a little vocab for you. Now we're going to get into the actual solving. So in order to solve these, we're going to be following along and using the zero product property for today's lesson at least. And it says if the product of two quantities equals 0, then at least one of the quantities equals 0. I'm going to take my paper away here for just a second and go to my dry erase board and just try to really hammer this point in. So if we have two quantities, so there's my first quantity, here's my second quantity, we're multiplying them together and they equal 0. Well, remember, 0 times anything is 0. But is there any way to get 0 without having a 0 over here? Could 2 times 1? Well, no. 3 times 7? No. What if we put a negative in there? Well, still no. The only way we're going to get 0 for an answer is if at least one of these is 0. And so either A equals 0 or B equals 0. And so, in a sense, the equation will split. So that way, either one factor is equal to 0 or the other factor is equal to 0. And that's what the zero product property is telling us. So I'll put that back up there. So to get to the heart of the matter, in order to solve a quadratic equation using factoring, we have 4 basic steps to follow here. So step number 1 is to set the equation equal to 0 if it has not already been done so. So basically turn it in a standard form. Step 2 is to factor if it's not already factored. And then step 3 is then to split it. So to set the factors equal to 0, in other words, we're going to use the zero product property. And then step 4, solve. Well, ladies and gentlemen, to help us out with this today, we are going to take a look at the practice problems today. So if you would open up your books to Lesson 98's practice set, and I believe that is on page 659. 659. So, A, we're given the equation x minus 3 times x plus 7. So the quantity x minus 3 times the quantity x plus 7 equals 0. So first of all, step 1, set the equation equal to 0. Well, that's all set. Step 2, factor. Now, this is obviously factored. We do need to give a quick glance, and it's going to be very quick, just to make sure there's nothing we can factor out of this and nothing we can factor out of that. No. So actually, steps 1 and 2 are already set here for this. So we're going to move on to step 3 then. We are going to set the factors equal to 0. So if x minus 3 times x plus 7 equals 0, then either x minus 3 equals 0 or x plus 7 equals 0. And solve. Add 3 to both sides. So x equals 3, or subtract 7 on both sides. X equals negative 7. And so my solution set here is 3 and negative 7. And there it is. Now I'm running out of room here a little bit. I'm going to go to the back now. So B, we're going to find the roots. Oh, find the roots is just another way of saying solve. So I have x squared plus 3x minus 18 equals 0. Step 1 is to set the equation equal to 0. We're all set. Step 2 is to factor. So I want to factor this. I want to consider, can I find something times something that gives me a negative 18, but then when I add those numbers, I get a positive 3. Well, negative 18, that could be a 6 and a 3, could give me an 18. And in order to add them and get a positive, that means the 6 would have to be positive. So positive 6 times a negative 3 gives me a negative 18. But when I add a positive 6 with a negative 3, I get a positive 3. And then this is still equal to 0. Step 4, set the factors equal to 0. So split it. So either x plus 6 equals 0 or x minus 3 equals 0. And now solve. Minus 6, so x equals a negative 6, or add 3, x equals a positive 3. So my solution set here, my set of roots, we could say, would be negative 6 and 3. Moving on to letter C. Here I have 2x squared plus 13x plus 15 equals 0. Step 1, set the equation equal to 0. Well, already done. Step 2 is going to be to factor. So if I want to factor this, first of all, I know it's still going to be equal to 0. So remember that we're going to consider what times what could be here and what times what could be there. Now with a 2, that makes things kind of nice for me because it's prime. I know that one of these will be a 2x and the other will just be x. There's not really any other way to split that. Now with a 15, I could split this up into 15 and 1 or 3 and 5. So if I split this up into 15 and 1, if I put a 15 here and a 1 there, and if we think about foiling that, I'd have 2 times 1, and then 1 times 15. Well, add those together, I'd get 17. That's not going to work. So then what if I consider switching that around, and I put the 1 here and the 15 there? Well, then 2 times 15 is 30. Well, that's way too big right there. Well, that's out. Okay, so 1 times 15 isn't going to work. So what if I choose 3 and 5? So what if I put a 3 here and a 5 there? Well, then if I FOIL, 2 times 5 would be 10. 1 times 3 would be 3, and 10 and 3 makes 13. We have a winner. So plus 3 here and a plus 5 there. So ladies and gentlemen, I highly, highly, highly recommend that you double check yourself and FOIL these. Even if you don't write it down, at least do it in your head. FOIL these to make sure that you've done this factoring correctly. So I have done that. I did check my foiling there. So now I'm going to move on to step 3, which is to set the factors equal to 0. So split it. Oh, I don't need the parenthesis anymore because we're splitting it. 2x plus 3 equals 0, or x plus 5 equals 0. So if we go ahead and solve this then, over here, I'm going to subtract 3. So 2x will equal a negative 3. And then I'm going to divide both sides by 2. And therefore x equals a negative 1.5. Or subtract 5 on both sides, and x equals a negative 5. So my solution set will be a negative 1.5 or a negative 5. D, we're given 5x squared minus 20x equals 10x minus 45. So step 1 is to set this equal to 0. So here we are, we're finally at the point where, well, it's not equal to 0 to start. So let's get this equal to 0. I'm going to leave my x squared on the left. We just kind of like it there. So let's leave it there. And so I'll start with subtracting 10x on both sides. So I get 5x squared minus 30x will equal a negative 45. And then I want to get rid of this negative 45, so I'm going to add 45 to both sides. And so I'll get 5x squared minus 30x plus 45, and then those will cancel, leaving a 0 behind. So now that we have this set equal to 0, I'm going to go ahead and take a look at it if I can factor. Now, ladies and gentlemen, don't forget the often overlooked first step. First step we should consider, is there something we can factor out of each of these terms? So a 5, a 30, and a 45, obviously I can factor a 5 out. And so when I do, that's going to make this factoring much simpler. Much simpler. And it's still equal to 0. So I'm going to continue to factor this. And maybe you've noticed what I've noticed here. We'll see if you have. This is actually a perfect square trinomial. So this is x squared, obviously. This is either 3 squared or negative 3 squared. So if you take a negative 3 and an x, multiply them together, and then double it, you get a negative 6x. So this is actually x minus 3 squared that's equal to 0. So ladies and gentlemen, if I go ahead and split this one, set the factors equal to 0, then we're going to have a situation where either 5 equals 0, which we know won't produce any results. That'll never happen. Okay. We are going to get an x minus 3 equals 0, but since it's squared, there's technically 2 of them. So we get another x minus 3 equals 0, and I put that in red because do we really need it twice? Well, obviously not. So if you end up in a situation like this, instead of having to write your x minus 3 twice, you know it's going to come out with the same answer. Just write it once. So now if I solve this, I'm going to add 3 to both sides. And so x equals 3. So my solution set here, this would be a situation where actually, unlike the previous examples that we've done where there's always been 2 roots, this time we only have 1 root, which remember if we relate that back to the graph, if we were to have graphed this out as a function, so if we take this standard form, and if we were to replace the 0 with f of x, what this means is that the vertex is actually on the x-axis. All right, so we're going to keep moving here, and I'm going to split my page, try to save some paper so I don't have to go on to a new sheet of paper. And we're looking at E now. So E gives us 45x squared equals 27x. So step 1, set this equal to 0. So I'm going to subtract 27x from both sides. And so that'll be 45x squared minus 27x equals 0. Step 2 is to factor. So notice that I can pull a 9 out of each of these. And then I can also pull an x out of each of these. And so that will leave behind a 5x and a minus 3, which then has to still equal 0. Well, once again, ladies and gentlemen, the next step is to set the factors equal to 0. So my factors now are 9, x, and the quantity. So this means if I were to split this apart, that either 9 equals 0, which obviously we know it doesn't, or x equals 0, or 5x minus 3 equals 0. Well, we already have one solution right here. X equals 0 would be a root or a solution. Now over here I'm going to have to do a little bit more solving, so add 3 to both sides, so 5x equals 3. Divide both sides by 5, x therefore equals 3/5. So the solution set to this equation is 0 and 3/5. F 25x squared minus 16 equals 0. Step 1, done. It's already set equal to 0. Step 2, factor. Now, ladies and gentlemen, I hope that you are getting your special products memorized because you should recognize this as one of them. So a little bit earlier, we had created a perfect square trinomial. This time we have a difference of squares. Remember that a difference of squares means that this is the product of conjugates. So this is going to be 5x plus 4 times 5x minus 4. That equals 0. Set the factors equal to 0. So either 5x plus 4 equals 0 or 5x minus 4 equals 0. These are going to solve very similarly. I'm going to subtract 4 on both sides here, but I'll add 4 on both sides there. So this will give me 5x equals a negative 4. This will give me a 5x equals a positive 4. Divide both sides by 5. Divide both sides by 5. So over here, x equals a negative 4/5, or over here, x equals a positive 4/5. And so my solution set is a negative 4/5 and a positive 4/5. And last one, G. A rectangular pool has an area of 360 square feet. The length is 6 feet more than 3 times the width. Find the dimensions of the pool. So, well, area is length times width. So the length, so if we think this through, area equals length times width. And we know that the length is 6 feet more. So 6 feet more, that's a plus 6. Then 3 times the width. So then 3 times the width. So find the dimensions of the pool. Well, that means that the area is going to be length times width. So length here is 3w plus 6. The width is just the width. And so when we multiply those together, that gives me my 360 square feet. So don't forget at the end, we're going to have feet as our dimensions. Now the thing about this one is we got to set this equal to 0. Now if you just subtract 360 from both sides, we're not going to get something that we can factor. So the first step that I'm going to take here is going to be to distribute my w in. Now if I subtract 360 from both sides, we will get something that we can potentially factor. Oops. Now, first things first, let's start by dividing by everything by 3 there, factoring out a 3. And so now we're going to see what we can factor here. So something times something needs to produce a sum of 2, positive 2. So that's going to be 3 times w something, and it still equals 0. Well, 12 times 10 comes to mind because there's a difference of 2 between them. And since it's positive, I need the 12 to be positive, which means that my 10 will be my negative. So multiplying those together will give me a negative 120. Adding them together gives me a positive 2. Now if we split this, obviously the 3 equals to 0 isn't going to do anything for me. So either w plus 12 equals 0, or w minus 10 equals 0. Subtract 12 on both sides here, and either w equals a negative 12, or add 10 on both sides there, w equals a positive 10. Now if we think about this, the width, can we have a negative width? Well, obviously not. So therefore the width must be 10. So width equals 10 feet. Well, the length then equals 3 times 10 plus 6, which would be 36 feet. So ladies and gentlemen, when we have a real world problem like that, sometimes we have to stop and consider, can both of our solutions to the equation happen in real life? And so when we get something that can't happen in real life, we eliminate it. We cannot have a width of negative 12, so the only width that's possible here is 10. And that, ladies and gentlemen, is the end of our lesson.